Welcome to Taiwan Talks. I'm Betty Chen. Recently, TSMC, the world's largest semiconductor manufacturer, and the U.S. Department of Commerce signed a preliminary memorandum of understanding. The U.S. government will provide TSMC with $6.6 billion in subsidies for constructing its third semiconductor fabrication plant in Arizona. This plan expands TSMC's investment in a region to $65 billion, making it the largest foreign investment in Arizona's history and the largest foreign direct greenfield investment in the U.S. Today, we have experts join us to analyze TSMC's global strategy. Joining us today are Marco Mezger, Neumonda Executive Vice President and COO, and Tri-Rung Yew, National Tsinghua University Department of Materials Science and Engineering Professor. A warm welcome to both of you on the show. Under the CHIPS and Science Act, also known as the CHIPS Act, the U.S. government provides TSMC with $6.6 billion in direct subsidies and $5 billion in loans to build advanced semiconductor manufacturing facilities. Let's hear from the U.S. Commerce Secretary, Neumonda.
This will be the first time in a very long time that we'll be making these leading-edge chips in America. Right now, the U.S. makes 0% of these leading-edge chips in America, and TSMC is saying that they're going to start making this in America at scale.
Talking about the subsidies, TSMC receives $6.6 billion from the U.S. government, while Intel receives $8.5 billion and Samsung receives $6.4 billion. So let's start with today's discussion. We have seen these different figures for different companies. Why there is such a difference? Let's start with Marco.
Probably better negotiation power from the individuals, but I would say all these three big names, they are able to produce the cutting-edge technology. And I think in regards to the reshifting or more balancing of global supply chain, it made sense for the USA to lure these companies in with the subsidies in order to help to build up like a local supply chain for cutting-edge technology.
Professor, what's your assessment? Why is Intel getting the most among the three?
All right. I think all those amounts are very small fraction difference compared to the fab that we would have to build. But what I see is the partnership. It helps, and also the long-term partnership to begin with. So it's very positive, and in the long run, I believe they will continue to invest and more the support from the U.S. I believe so. So maybe the small amount of difference is not a major issue at this moment. What I see is more positive, the partnership long term.
So talking about long-term partnerships, TSMC has also laid out its plans in terms of building the second and the third plant. So according to TSMC's plans, the first fab will start producing 4nm process technology in the first half of 2025. The second fab will produce 3nm and use 2nm process technology, expected to start in 2028. And the third fab plans to use 2nm or more advanced technology, with production expected to begin in 2029. So they have this plan. Do you think that these plans are feasible?
Yeah,
Professor?
I believe so. See, the investment is a long-term growth and also the development. And for a company, such a big competitive company like a TSMC, globalization is a trend and it's necessary. So they have a very smart engineering team and also the management team to have the valuable assessment on this investment. And although in the beginning there are some culture shocks, but based on my understanding, I trust them can resolve all those issues like they used to do. So, but from my perspective, I see some advantages. The first thing, for the semiconductor technology, it needs the long-term investment and the technology innovation and collaboration between among the partners like vendors and the manufacturers and also the IC designer, the customer. So I see the advantage that the U.S., they had the best and the most of the competitive IC designers, and also the tool like Applied and Lam Research and SML in the U.S. And also you see that the close to the customers, right, is the good thing. They have very seamless communication and discussion, and also they can leverage their existing strengths on the technology and the talents. And then, also the very important to reduce the risk on the geographical issues. And in terms of price, I think you can just based on the living resource expenses in the local, right? So you can raise some amount of the price of the products.
So thank you for the positive feedback. What about you, Marco? What's your assessment?
Yeah, I think so too. We are talking about TSMC, right? I mean, TSMC has over 60% market share last year in pure play foundry. The three names you mentioned, Intel is not pure play foundry, so they have their own products, which is in also Samsung has a huge range of other products. TSMC is the master of execution when it comes to install equipment, cutting edge technology, and they have proven this here in Taiwan, and now they're expanding this. I think, Professor, what you mentioned, I fully agree, is not only the investments itself, because it's a small amount comparing to what TSMC has to pay, but what it really helps is to open up TSMC regional to the world. So this means like you need to establish as TSMC from headquarter, like local supply chains. I mean, it's not only TSMC goes there. You need to have the chemical companies. You need to have like all the sub-suppliers around there. So there's a complete ecosystem which is built up. And that's actually what the world is looking, especially after the pandemic, to make a more resilient supply chain locally. But please don't make a mistake, because even if these factories are built up, the majority of the wafer output, especially for cutting edge technology, will be produced in Taiwan and will remain in Taiwan. Because here you have the very close ways, literally, you have very short distances. You have like the universities who are working very close together. You have EP3, which is doing this since decades. So this is an ecosystem where I always say this is an establishment where I always believe the lion's share of moving into new technology will remain in Taiwan.
Thank you for your contribution. TSMC plans to build 3 fabs in Arizona, but due to the cost of manpower and also resources in the U.S. is actually higher, so there have been some delays in terms of the construction. And also, although they have received government subsidies, but that only accounts for 10% of the total investment. So overall, do you think that the investment for TSMC to build 3 fabs in the United States, do you think it's cost effective?
Just with the subsidies alone, no,
it's quite small, right?
Yeah, it's quite small. I mean, we're talking about billions, right? This is still a lot of money. But ultimately, if these subsidies later are gone, the company needs to be profitable, right? So we need to think beyond. So it's kind of a starting point to maybe make a decision more easy, more favorable. But ultimately, these companies they're private organizations. They're on the stock market. They need to provide a return on investment for their shareholders. So I think all the decisions they are making, they need to make with having in mind how they turn this into a profit business.
Professor, what's your take on this?
Yes, I fully agree, because in the long run, this is a good investment because the local talents, local technology leveraging. And also the, TSMC has a very good management team. They did very careful assessment for all the investment, and they have very strong execution in the past. And also the most advanced technology is very hard to catch immediately.
Right.
So they will keep the strengths and also the competitiveness for a while. And of course, because of demand on AI chips, and I believe they will make a profitable, investment.
We know that semiconductor industry is so important for the world, but I think not just the semiconductor industry, actually in a lot of different industries, people are facing one common issue, that is lack of talent. And also, Professor has mentioned cultural shocks a few times. So Taiwanese company TSMC has its own culture, its leadership, its management structure, but now having to tap into a different culture, different country, and meeting different regulations. How do you think that TSMC is going to address these difficult issues, including talent and culture? Professor.
TSMC has done a lot in recruiting talents. including in Taiwan. They give a scholarship. Not just Taiwan, they work with like MIT, Stanford before to get talents. And this time, because there's a big fab moved to Arizona, of course, in the beginning, they will have some of the culture shock. And my suggestion is fit into the culture, blend into the culture, and including the payment compared to their local payment, and also the work-life balance. Though they may not fully agree my points, but that's the long term. You can invest on the talents that keep them work-life balance, and in a smart way. For instance, the automation, and also some more effective training, and also the talents cultivation. Yeah, I think that will work, and I believe they will make it happen.
So definitely talent is very important, but I read on some articles online saying that the reason why TSMC is facing some difficulties is because under the CHIP Act, there is a special clause regarding DEI. So that includes diversity, equity, and inclusion, and that may cause some restrictions in terms of recruitment. So Marco, do you have any suggestions for that? How can TSMC address this issue?
Well, I think first of all, they will select people based on their talents, right? And I think one advantage for TSMC is like, it's basically the company to go if you want to work on cutting edge technology, right? They work with the biggest equipment manufacturer. They have the largest semiconductor customers. So if you want to go and work in this industry, that's definitely a good start to understand the technology. So in order for the hiring process, how they select this, I think there are specific programs. And I know, especially, for example, in the US, that there are some programs where even people outside the industries, I'm not only talking about PhDs, like highly classified ones, because somebody has also like operator use the machine. So they have training programs where they look for people from different industry. They get kind of pre-qualified for around about 3 months and see, okay, which one would be feasible to go in working into a semiconductor fab, and they move them in. So I normally would say that even under the CHIPS Act, if there are some restrictions, first of all, they are not applying only to TSMC, they apply to all of them.
Yes.
And I think in regards to this, the play field is leveled out, and they have the same challenges than the others, I would say, but they can tackle it.
So now let's shift our focus to other countries, because the TSMC has not only expanded its presence in the United States, it has also opened up new fabs in Japan, in Kumamoto, and also in Germany. So we can see that Kumamoto plant in Japan is already completed, and the ESMC, European Semiconductor Manufacturing Company in Germany, is set to start building the fab by the end of the year. So what's your observation regarding TSMC's development in Japan and Germany? Professor.
Yeah, in Japan, I think there are advantages of the similarity in the culture, and also it's very near to Taiwan, so they're easy to communicate. And the other thing is that if you look at the Japanese government and the vendors, suppliers, and people, they are really welcome at TSMC and also put all the efforts to make it happen. And they want like to regain their strength on the manufacturing technology. So now, if you look at that, they are very, very aggressive to do that. And so that's why I think they are a very, very good move in the beginning.
Marco.
Yeah, I mean, just to close it, I also fully agree on the cultural similarity, you know, like highly disciplined, focus. I mean, Japan has been one of the leaders in semiconductor, but this was like a few decades ago, right? So they are very serious about that they want to go in. So I had the chance, I was there a couple of weeks ago, I was there at the conference, there was METI, like the government organization there, Rapidus was there. So it's quite amazing how they are focused there. And they have all the sub-suppliers, right? Chemicals, so there are a lot of these companies. So that's really great. And I think that's, I probably believe it's the only area where TSMC goes, where everything goes smooth, right? So they are in line with everything, opening up, so everything is good. So, well, I'm originally from Germany, so I'm happy. I'm happy that also TSMC comes to Germany. I think they make a good choice with Dresden, like the Silicon Saxony, where already several companies are there. So there's Bosch, there's Infineon, Global Foundries. So I think it makes sense for TSMC to go there. And as you mentioned, so I think it's approved now. They are building up. What is quite interesting, what I've seen with Germany, there are already special programs between German universities and Taiwan universities where they have students. I think the first one was 100 students. Josef Goldberger, I think he is installed as a person here who is managing to bring these people over and train them in the semiconductor. So I think Germany has started very early to say, okay, if we bring them in, we need to make sure how we build up the talent. So there's a good hype right now to bring people more into the semiconductor industry, because the younger generation, you know, electrical engineer is not something where the young people want to go, right? They want to go to e-commerce companies, you know, social media companies. So you need to inspire them to go there, and I think that's basically what is happening.
May I have
Please,
two more points? For Japan, I think they already have very strong technology on materials and tools, semiconductor tools. And in Germany, I believe they also have very good technology, including the RF, 5G, MEMS, car, transportation, all the system chips and MEMS chips. So I think it's a very good synergy between Japan and Taiwan, also Germany and TSMC. I think that's for sure. It will be very good, collaboration.
So we have talked about a positive development in the industry, semiconductor industry. So now let's shift the gear. Let's look at something quite different here. The semiconductor battle, or you can say the battle between the US and China, continues to escalate. US President Joe Biden recently announced revisions to prevent China from acquiring US AI chips and manufacturing equipment for national security reasons, with the related legislation effective in April. Japan also followed the US lead by announcing plans in late April to impose export controls on semiconductor and other related items. So President Biden has revised the CHIPS law again. So what are the key changes in this revision, and how is that going to impact China? Let's start with Marco.
I think USA tries basically to limit new technology, cutting-edge technology, especially in the way of AI, where you have high processing power, where you have like certain limits of throughput, how fast the data can go through, or parallelism. These restrictions have been addressed by some of the manufacturers before, so they make some light version, as you can say. So NVIDIA was making chips who had basically like a little bit of a lower performance. Intel is looking into this. But we also have to see that because of these restrictions in China, there are many companies, they are pushing internally for chip solutions, so that they are not relying on the US-based solutions, right? Of course, they are not there yet, but I think because they have no other solution, there is more investments also from the government or funding going there to be more self-sufficient, let's put it this way.
So as mentioned before, now Japan is following the footsteps of the US and trying to impose such kind of restrictions on its export of semiconductor products to China. Do you think that this will be an effective method for, say, the alliance, for example, US and Japan, blocking Chinese from getting these semiconductor products, Professor?
Yes, I believe so. You know, like I mentioned, advanced technology takes a long time to development, and also very seamless collaboration among vendors, suppliers, manufacturers, and IC designers. So if I look at China, they can get some chips and develop by their own mature chips or develop mature technology, but it's still very hard to catch up. So all those policy will slow down their growth and development. That's good because for technology you need allies, but now they lose allies because of the policy in their government. And so if we can just work together, not to get the advanced chip, of course, the other thing is the third party. Sometimes they are hidden channels to the US. For instance, this time Biden mentioned that even at their top, you have advanced chip, you cannot get in there because they can take advantage of other products to get the advanced chips. So if we don't do that act or that new stringent rules, they will get the chips eventually. And then our policy will become in vain. So it's very careful to avoid that kind of hidden channels to China, okay? So as to slow down their,
I'm just curious, hidden channels aside, can China just rely on itself in terms of the semiconductor development, or does it still have to rely on other countries for assistance?
Well, I think in the China 2025 plan, originally, they wanted to have a self-sufficient rate of chips by around about 70%. 2023, they are around about at 23 based on Tech Insight. And 50% of this is related to international companies who have manufacturing sites there. For example, also TSMC. So we're talking about 12, 13% self-sufficient rate in 2023. So we need to separate probably also when we talk about chips and equipment, right? So the equipment manufacturers. So there's already a very effective ban, for example, on EUV technology.
Right.
So EUV, there's only one company in the world who has the technology. So when you ban this, you have no access. And I think, based on my understanding, I also would say China is not able to do the EUV technology, right? Because it took like ASML so many years and so many cooperation with other companies, not possible. But there's basically several ways to Rome, right? So this means, and we have seen this in the past, you know it, right? So we have seen some smart ways how they can further go down and shrink the nanometers, go down to 5 to 7 nanometer.
Right.
The question what we don't know is how is their yield? How effective is it for mass production, right? Because for any other company, this is very important because it's vital to your profitability where you can invest. So this is a little bit different in China because you have support from the government who wants to make sure that you are getting more and more self-sufficient. And I think the word blocking is not really stopping, right? This is just to be very clear. So it slows down for sure, but I think it accelerates at the moment major process nodes. That's probably where I think Western foundries will find out that when you talk about 20 nanometer and above, I think in China, the capacity will be in the next 2 years probably double. And so this means they cannot go into the cutting edge, so they will own major process nodes. And this means the cost will come down massively down. And global companies, global foundries have to compete with this price. And if the customers are not using it, there will be end products on the market who have access to this technology. So that's another challenge, right? So I think I'm fully in line, Professor, what you mentioned in order to, with the access of the cutting edge technology. But if you look at the big bulk of the market, there will be another issue created when we're talking about major process node, because there they have access still to.
Right. So here's my final question. According to Taiwan's think tank, MIC Market Intelligence Consulting Institute, Taiwan's semiconductor industry is expected to see a 13.6% increase in output value this year. So how do you see the semiconductor industry in the second half of the year? Is it promising? Professor?
Okay, is this the last question?
Yes.
Okay, I have some points to address.
Please.
Yeah, yes, in the second half, to answer your question first, I think the advanced node, integrated circuits, AI chips will grow in democratic countries and free countries, and because of the demand. Okay, and if the mature node, like Mark mentioned, China, they have brute force and government support to have the massive capacity. So that will hurt the industry, because if we don't dump, if they dump the wafer to the existing countries, and then the price and everything will be destroyed. So the growth in China will be very much. So we have to limit their growth in China. Otherwise, all other countries will become a headache. And I also would like to address that you see some of the Taiwan companies pull out, and some companies pull out from the China. And I would say that it's a new wave, and I believe that will continue. The reason is that for the advanced technology, unit allies, even they make it by their own, by the government support. But you see in this innovation, also the collaboration between the very competitive companies. So I think it's very hard to stay there, especially for business. You need to make profit, right? If you face a government, they don't have consistent rule to follow, and someday, you don't trust them, and government don't trust you. They have censorship. And then you will lose the money. Someday you don't know what's the reason, or suddenly you lose it. So that's why I think why the new wave will pull out from China. And the most important thing I would say that for business, national security always number one.
Yes.
And then trustworthy government and the consistent rule to follow is number two. And the third is that you have to do the right things to the society. And if they're a dictatorship country, or they have censorship on people, or harassment to other countries, or even want to invade them. So we should not, or it's not proper to judge them by the democratic countries' concept, right? So we have to be careful. It's very dangerous, because someday we may lose everything. The way we live, the democratic, the countries, the society, and also the freedom and human right. So I urge all the companies, making money is important, but do the right things, even more important, because that's the way we live. We have to trust that that's the right thing to do.
Yes, thank you very much. So indeed, Professor,
it's
you
like
just
a professor,
said that.
right?
Yeah. You're just like you're indeed a professor. So you talk about the importance of semiconductor, which is critically important for our national security. So thank you very much. If you like our show, please search for us on YouTube, give us a thumbs up, and hit subscribe to our channel. Thank you for watching our show today. Stay safe and see you next time.